2 supermassive black holes have been spotted feasting on cosmic materials as 2 galaxies in distant space merge, and are the closest to colliding black holes astronomers have ever observed. Astronomers spotted the pair while using the Atacama Large Millimeter/Submillimeter Array of telescopes, or ALMA, in northern Chile's Atacama Desert, to observe 2 merging galaxies about 500 million light-years from Earth. The 2 black holes were growing in tandem near the center of the coalescing galaxy resulting from the merger. They met when their host galaxies, known as UGC 4211, collided. One is 200 million times the mass of our Sun, while the other is 125 million times the mass of our Sun. While the black holes themselves aren't directly visible, both were surrounded by bright clusters of stars and warm, glowing gas, all of which is being tugged by the hole's gravitational pull. Over time, they will start circling one another in orbit, eventually crashing into one another and creating one black hole. After observing them across multiple wavelengths of light, the black holes are located the closest together scientists have ever seen, only about 750 light-years apart, which is relatively close, astronomically speaking. The results were shared at the 241st meeting of the American Astronomical Society being held this week in Seattle, and published Monday in the Astrophysical Journal Letters. The distance between the black holes is fairly close to the limit of what we can detect, which is why this is so exciting, said study co-author Chiara Mingarelli, an associate research scientist at the Flatiron Institute Center for Computational Astrophysics in New York City, in a statement. Galactic mergers are more common in the distant universe, which makes them harder to see using Earth-based telescopes. But ALMA's sensitivity was able to observe even their active galactic nuclei, the bright, compact regions in galaxies where matter swirls around black holes. Astronomers were surprised to find a binary pair of black holes, rather than a single black hole, dining on the gas and dust stirred up by the galactic merger. Our study has identified one of the closest pairs of black holes in a galaxy merger, and because we know that galaxy mergers are much more common in the distant universe, these black hole binaries too may be much more common than previously thought, said lead study author Michael Koss, a senior research scientist at the Eureka Scientific Research Institute in Oakland, California, in a statement. What we've just studied is a source in the very final stage of collision, so what we're seeing presages that merger and also gives us insight into the connection between black holes merging and growing and eventually producing gravitational waves, Koss said. If pairs of black holes, as well as merging galaxies that lead to their creation, are more common in the universe than previously thought, they could have implications for future gravitational wave research. Gravitational waves, or ripples in space-time, are created when black holes collide. It will still take a few 100 million years for this particular pair of black holes to collide, but the insights gained from this observation could help scientists better estimate how many pairs of black holes are close to colliding in the universe. There might be many pairs of growing supermassive black holes in the centers of galaxies that we have not been able to identify so far, said study co-author Ezequiel Treister, an astronomer at Universidad Católica de Chile in Santiago, Chile, in a statement. If this is the case, in the near future we will be observing frequent gravitational wave events caused by the mergers of these objects across the universe. Space-based telescopes like Hubble and the Chandra X-ray Observatory and ground-based telescopes like the European Southern Observatory's Very Large Telescope, also in the Atacama Desert, and the W.M. Keck Telescope in Hawaii have also observed UGC 4211 across different wavelengths of light to provide a more detailed overview and differentiate between the 2 black holes. Each wavelength tells a different part of the story, Treister said. All of these data together have given us a clearer picture of how galaxies such as our own turned out to be the way they are, and what they will become in the future. Understanding more about the end stages of galaxy mergers could provide more insight about what will happen when our Milky Way galaxy collides with the Andromeda Galaxy in about 4.5 billion years.